Hello everyone and welcome back to the course. In this lesson, we will learn about traces, what they are, and how to use them. Let's get started. Now let's take a moment to learn about traces. So what is a trace? Traces, also known as raycasts, are a way of shooting an imaginary ray or shape into the world to get some information. The ray will collide with objects in the world and return valuable information that we can use in our code. Information such as location of the hit, the actor that we hit, the distance between the origin and the hit, etc. Traces, like overlaps, are part of the chaos physics system and use collision settings available to all actors in Unreal. There are many different types of traces available in Unreal Engine, and they are organized in three categories. By shape, you have the line, box, capsule, and sphere traces. By type, you have channel, object, and profile traces. And by detection mode, you have single and multi traces. For this lesson, we will only look at line traces. However, everything we will learn applies equally to the other shapes mentioned here. Now let's jump into Unreal and see an example. Now before we look at a specific example, let's take a look at the different types of traces we just talked about. So if we go to the settings, project settings, and we scroll to the collision section here, you can see that we have object channels, trace channels, and if we expand here, we have the presets or the profiles available as part of the chaos physics system. Remember, traces use the same collision settings that we talked about earlier in our collisions lesson. So if you want to trace for objects, you will have the default object channels plus any new object channels that you've created here. If you want to trace for channels, you'll have the default camera and visibility channels and any custom trace channels that you add here. Or if you want to trace for profiles, you can then use any of these profiles here, or again add a new profile to your project. Okay, so for the first example, we will do a single line trace by channel. This is perhaps the most common line trace that you will use in your projects, so I figure we'll start with that. And it makes sense that we will add it to our player character. That way we can press play and move around and shoot our rays in the world. So let's go ahead and go to the third person and blueprints folder here. Double click third person character. And right here in the event graph, let's go ahead and add another input event. In my case, I'm going to add the F key, so go ahead and do that. And now we'll create a new function, so click on the plus sign here, and let's call this FN trace. Let's go back to our event graph, and we'll drag our function and connect it to our key. And let's go back to our function, and we'll drag from FN trace and search for line trace. And we'll select here line trace by channel. And as you can see, the line trace node has a lot of input pins. The start and end locations are going to be the most important information that we provide, right? Where does the line trace start and where does it end? We have the trace channel, which right now we have by default visibility and camera. We have whether we want to trace complex, and by default is false, meaning we are tracing against a simplified collision for meshes, or we are using the complex collision when we're doing the traces. We can supply an array of actors here that the line trace will ignore, and we have several different debug types. In this case, let's go ahead and select it and choose for duration. And if we expand here, you can see that we have several options for debugging, such as the trace color, the hit color, and the draw time. So right now when we shoot this ray, we will see the ray for 5 seconds for duration. Now before we add the start and end locations, we need to understand a little bit of vector math. So let's go ahead and do that first. Now let's take a moment to learn about orientation in 3D space. As you probably know, in Unreal Engine we have 3 different axes to show orientation: the X, the Y, and the Z. But most importantly, Unreal Engine's convention is that the X direction is the forward direction, the Y direction is the right direction, and the Z direction is the up direction. This is important to understand if you need to calculate a direction in 3D space. And it follows that if we want to calculate the opposite direction, say the backwards direction, all we need to do is multiply the forward direction by -1. With this method, we can get the backwards, left, and down directions. So now let's think about what we need to do if we want to calculate an end destination from a starting location. As a simple example, imagine you are standing in a field and have to walk from your current location to an arbitrary destination, the end location. You would rotate towards your destination and start walking forward towards the destination until you arrived. In code, we would do exactly the same. We can start with a start location, and then we can travel the distance between the start and end locations in the direction of the end location, arriving at this simple formula. The end location equals the start location plus the distance in the direction of the end location. So if we face our destination, then we can use the forward direction, or X, as our direction. So now that we understand 3D orientation in Unreal Engine and how to calculate our end destination, let's go ahead and add our information here step by step. First, we'll add the start location, which is the easy one. That would be our player location. So go ahead and right click and search for Get Actor Location. And go ahead and connect it to the start pin. And with the Get Actor Location node selected, go ahead and press the C key on your keyboard. This will add a comment box to your code. This is a very easy way to keep your code organized. So in this case, I will simply add start location. There you go. Now we have our start location, and based on the formula as you can see on the screen, our end location will be our start location, which we already have, plus the distance in the direction of our end location. In other words, we need to decide which orientation we will be shooting our ray and then define a distance in that orientation. So in our case, we want to shoot a ray right in front of the player. So in other words, in the forward direction of our player. So we can do that by getting our player's rotation in the world first. So let's do that. Right click and search for Get Actor Rotation. And from our rotation, we can simply drag and search for Forward Vector. These two nodes represent the forward direction in world space of our player character. Now we just need to specify the distance in our forward direction that we want to travel, and then add it to our initial location, and that will give us the end location. So now let's define our distance by creating a new variable. So let's go ahead and click on the plus sign here and type trace distance and make this a float. Let's go ahead and compile. And now let's drag our trace distance to the event graph. And all we need to do now is multiply our forward vector by our trace distance. So let's drag from the return value type here and search for multiply and simply connect our trace distance to the pin. As you can see, this automatically converts to the appropriate node to multiply a vector times a float. And the last thing we need to do is add our distance to the start location here. So drag from the Get Actor Location node and search for Add. And now connect the node here. And finally, connect the resulting pin to the end location. And now let's select the nodes here and add a new comment. And this will be the distance in the forward direction. There you go. Let's go ahead and compile and save. Now let's go ahead and look at the trace results. So let's make some space here. And if we drag from the out hit and click on break hit result, click on the little arrow to expand, you can see that our trace is going to provide a break hit result struct with a lot of different information. Just for testing purposes, let's go ahead and pick a few items here to display. We can do that with a print string. So let's drag from here and add a sequence node. And the first thing we'll add is the distance. So let's drag from here and add a print string. Let's make sure that the print string lasts for a little bit longer so we can see the information. So click on the little arrow here. Let's make the duration 5 seconds. And now let's add an append node like we've done before. Let's go ahead and add the distance first. So let's type distance here. And we can connect the distance float directly into the B pin, and Unruh will automatically convert it from a float to a string. Now let's go ahead and do the same thing for the location of the hit and the actor. Okay, and now we're going to print every time we shoot our ray the distance to the object that we just hit, the actual location in world space, and the actor display name. So let's go ahead and compile. Oh, and just before we go to our level, let's make sure that we actually add a trace distance here. So click on trace distance. And right now it's 0, so our ray would basically go nowhere. Let's make this 5,000. Now let's go ahead and compile one more time, and let's go to our test map and click on play. Alright, and let's go ahead and face any wall and press our key. And as you can see, we are shooting a ray from the player's location forward by about 5,000 units and hitting the wall at the end. And you can see that we have the information printed on the left side of the screen. So let me press that again. You can see that the actor is called SM3. We have distance there and the actual location in world space. So if you move around, let's try this wall here. You can see that we have much shorter distance here at 338, SM4. This one is called SM2. Now let's go ahead and stop our game here. And if we select any of these walls, let's scroll all the way down to the collision section. They will be using the default preset, but if we change that to custom, all of the same options will be kept. And you can see that the object type here is world static, and we have block for all of our trace and object responses. So right now our trace is using visibility, and right now this wall is blocking our visibility trace, which is why our trace can hit the wall and return that information. Now let's go back to our blueprint and make a small change here. Right now we're using the player location and the player's rotation, which if you think about it is really the mesh that represents the player. But to make things a little bit easier to control, instead of using the actual actor location, why don't we use the follow camera location and rotation? That way, as we move our mouse and wherever we look, we can shoot the ray in that direction and actually hit something. So let's go ahead and drag our follow camera and let's get the world location. And we're going to replace this nose with these so we can control and click. And we can now connect both of those wires to this new pin here. And we'll do the same thing. We'll get the follow camera and we'll get the world rotation. And again, we'll replace this pin with this one here. So instead of using the actual actor location, we're using the location and rotation of the follow camera. So now if I compile and I go back to my map and click on play, you can see that if I look down with my mouse and press F, you see that now we have a ray that is being shot from the follow camera, which is behind the player, all the way to the floor. And this way, it's a little bit easier to aim our array. You can see, and if I look up, you see that our array is shooting up. All right, let's go back to our player. Now for the next example, we're still going to use a single line trace, but instead of using it by channel, we're going to do it by object. So we're going to right click and search for a line trace. And in this case, you see that we have line trace by channel, by profile, and we're going to select line trace for objects. And the node is almost identical to the trace, except that we have an additional array of object types here. So let's go ahead and disconnect all of the information here and connect it here. And now we're going to move this node down, and everything should work as expected, except that now we have to specify the object type. So we can click and drag, and we can type make array. And now you can see that if we click on the drop down, we have all of the object types, including our custom boulder type that we can select in the list. So if we select world static and click on compile, now we're going to be tracing only for world static objects. So let's go ahead and test that out. Click play. And now if we face this wall right here and we press our key, you can see that we're still hitting the wall. We just can't see it. We forgot to do something. So let's go ahead and stop. Go back to our player character. And right here on draw debug, let's again select for duration. Let's enter 5 seconds here. Actually, it already has 5 seconds, so all we need to do is do the debug. Now one more time, let's compile and save. Press play. Press our key. Now we can see the array that is hitting the wall SM3 Now if we look at our platform here and we shoot our array, oops, let's just stand on top of it and make it easier. You can see that our array is not hitting our platform, but instead is hitting the floor. And if I stop, we'll see why. If I click on my platform here, this is our BP platform from our previous lesson, and we select our cube, which is the component that is being hit. If we go back to the collision settings, we notice that the collision preset is block all dynamic, and the object type is world dynamic. So in our case, because we're only tracing for static objects, this blueprint is ignored. If we go back to our player and we click on the add pin, now we can add world dynamic. If we go back to our map, let's see if we can now hit our platform. Back and stand on it. And now you can see that we can actually hit our platform. You can see BP platform B. Let's go ahead and stop. Go back to our player. So you can see that we have a little bit more control when we're doing traces for objects, because not only can we add as many different types of objects to the array here, but of course you know that we can easily create custom object types that we can then assign to our objects in the world. Now for the next example, let's do the same thing that we're doing here, except we will do a multi-line trace for objects. So let's make some space here and right click and search for multi-line trace and select multi-line trace for objects. And again, we have the exact same nodes as before. So let's go ahead and replace the connections here. And now let's connect this pin here. And now you notice that instead of a single out hit, we have an array of out hits. Obviously, we're doing a multi-line trace. So in this case, we'll simply drag and search for each. And we're just going to go ahead and connect it like this. And now this out hit would be the array element. So we can now disconnect this wire here and connect it to the array element. And if you zoom out, what we're effectively doing is we're simply doing many line traces for objects, and for each individual one of the array, we are breaking the hit result, and we are then printing distance, location, and actor. the exact same thing, and we're also using world static and world dynamic. So if we go ahead and compile, we go back to our level. For this test, let's actually add some cubes to make it a little bit easier to see the results. So let's go ahead and click on the add menu, shapes, cube. Let's go ahead and resize this. Place it somewhere in the world here. See if this is the right place. Maybe a little bit taller. There you go. And now if we click play, and we hit our key, we can see that we are actually hitting this cube and the wall behind us, but we can't see the trace. One more time, let's go back to our player character here. And for debug type, let's select for duration. And let's try again. We can see that our ray is hitting our cube here and then hitting the wall behind. I'm going to do that one more time. And you can see that we have two different results, SM cube 6 and cube on the left hand side. And let's take this one step further. Let's duplicate our cube here. And let's hit play. And as you can see, we're hitting all three cubes and the wall behind us. Now let's go back to our character and do the exact same thing, but we will do a multi-line trace by channel. Let's go ahead and right click and type multi-line trace. And this time we'll select by channel. And one more time, we will simply replace the connections here. And we're doing the exact same thing, except instead of using object types, we are using the trace channel visibility. We're shooting array. We're going through the for each loop, and every single array element that we hit, we're breaking the hit result and printing the information. Go ahead and click compile. And let's go back to our map. And let's see what happens if we do the exact same test. And now if we click on our key, notice that our array is only hitting the first cube. Let's go back and make sure, one more time, I keep forgetting, to enable the draw debug type for duration. Let's make this a little bit longer. Let's make it like 8 seconds here. Let's try one more time. Notice that our line trace is only hitting the first cube. Now let's see why this is happening. So let's go ahead and stop. And let's select our first cube here. And let's go to our collision settings here. Roll down to collision. These are going to be default. So click here and select custom. This will preserve all of the settings here. And we can see that this is an object type of world static. But in this case, we're using our collision trace responses here. And you can see that we have block for visibility. The multi-trace by channel works a little bit different than the multi-trace by object. The multi-trace by object will shoot a ray for the distance of the trace and return every single object of the object type that overlaps or hits that ray. But if you use the channel response, the multi-trace will hit every single object that overlaps the channel until it hits an object that has that block response. In other words, because the first cube here had a response of block, the ray stopped there. But if I change this to overlap for visibility, and we click on play, now we're hitting the first cube, and the second cube is stopping the ray because it has a response of block. And that is a crucial difference to remember when you're using a multi-line trace by channel versus for objects. The multi-line trace for objects will simply return every single object it hits that is of the object type. Multi-line trace by channel works differently and this will look at the collision response for the channel. If it hits an object that has a block response, the multi-line trace will stop there, as you can see. But if it has an overlap, then the ray will continue until it hits a block. Now for this last example, let's go ahead and remove these nodes and go back to our original line trace by channel. And reconnect our line trace by channel as we had before. But now, instead of doing the sequence node, we're simply going to remove all this and drag from our hit actor and use our interface function to try to activate or interact with the hit object. So let's search for IN activate. And as you can see, all we're doing is using our line trace to hit our object and see if we can activate the object by using the interface BPI activate. If we go back to our event graph, notice that this is exactly the same thing that we're doing. But on our previous lesson, we were using a box overlap to see if we could interact or not with an object and then press the E key. In this case, we're going to skip all that and simply say, hey, we're going to do a line trace, and whatever we hit, we are going to try to send our activate message. Remember that we don't have to check whether the object has an interface or not. If the object does not implement the interface, this will fail silently and no errors will be produced. So now if we click compile, let's go back to our map and click on play. Notice that the door here, if I'm trying to go in, whoops. So one thing I just noticed is the door actually doesn't have collision. So if we shoot our ray here, let's see what happens. Notice that our ray is going past our door, so you can see here, and hitting the wall behind us because the actual door mesh doesn't have collision. So let's go ahead and fix that now. We can select our blueprint. Let's go ahead and click on Edit BP Door. Go to our viewport, and we can select our door here. And from here, we can go to the Details panel, Static Mesh, and we can click on this little icon here. And this will immediately take us to the actual asset, SM Door. And if we double click to open it, we are now on the Static Mesh editor here. And here's our door. And if we go to Collision here, and we click on, oops, not here, on Show, and click on Simple Collision, notice that this object doesn't have simple collision built in. So if we shoot a ray, we're trying to trace through the simple collision of an object. This object doesn't have collision, so the ray will simply go through the object. If we click on collision again, not collision, sorry. If we click on the show menu again and click on complex collision, notice that we indeed have complex collision, and that is the actual static mesh, all of the polygons of the actual mesh. We could trace for the complex collision by going back to our character and changing our trace here to trace complex, but that would actually cost a little bit more. So instead of doing that, what we want to do is we go back to our door. We want to generate a simplified collision. So what we do is let's go back to show. Let's remove complex collision here. So we are only seeing the simple collision. And now we can go to the convex decomposition window and we can just click apply here. And this will create automatically a simplified version of the geometry that will be used as simple collision, as you can see here. So now if we click save and we go back to our map, let's try that again. Notice that now we're actually colliding with our door, so our character cannot go through, so there's actual collision there. And if we go back, let's go a little bit farther and try to hit the door to activate it. And you can see that we actually hit the door, so it should be active now. And now, as we walk towards it, the door opens because it has been activated. Same thing with our lights. They're deactivated. So I'm gonna go back and try to hit it. It's gonna be a little tough here because it's a single line trace. Nope. I think I hit it. Nope, I don't think so. One last try. There you go, I do think I hit it. Let's see. Yep. Now this would be an excellent use case to use a different trace shape. We've been using line traces in this lesson, but you can just as easily use a capsule trace or a sphere trace, for example, and you would get the exact same results. We won't be going over those shapes in this lesson, but I will have some links at the end of the video and some recommended videos that you can watch on YouTube that will go over those specifics. Let's go ahead and stop and go back to our character. Now let's do a quick recap. Traces, like overlaps, are part of the chaos physics system in Unreal Engine. You can add custom trace, object, and profile entries to your project and use those settings with your traces. We have many different traces available in Unreal Engine, by shape, by type, and by detection mode. Traces provide a lot of useful information such as actor hit, location, distance, etc. And to fully take advantage of traces, we should understand basic vector math. To learn more about the types of traces we did not cover in this lesson, watch the videos from Matthew Watstein linked in the description below. He has excellent videos where he goes through all of the options per trace node. And to learn more about vector math, make sure you watch the Math for Artists Unreal Engine livestream linked in the description below. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.